Eigenvalues and Eigenvectors, presented by Monique D. Hutcherson and Leonard Gahn. In this presentation, we have Mr. Eigenman here to help us solve all of our eigen problems. He'll come in to help us make sure we answer everything correctly. How to find eigenvalues. When solving for eigenvalues, you can always start off with a matrix. In this explanation, we will call it matrix A. Two equations can be formed based on matrix A, using the coefficients from the matrix and relating them to variables x1, x2, and lambda. Lambda will ultimately be used to help us solve for eigenvalues. We use the identity matrix I to help us find the determinant and to solve for values for lambda. The determinant is another name for the cross product of the matrix. Once we take the cross product of the matrix, we end up getting a quadratic equation in which lambda is the only unknown variable. Therefore, we can use simple algebra to solve for lambda, and we end up getting values lambda 1 and lambda 2. Typically, you are able to get two eigenvectors for lambda 1 and lambda 2. In this example, we will only solve for the eigenvectors using lambda 1. However, typically solutions should be found using both lambda 1 and lambda 2. As you see, we are using the cross product matrix from the previous slide, and we're taking the dot product of this matrix with matrix X, which is represented by x1 and x2. After taking the dot product of these two matrices, we are able to obtain another system of equations. In this case, x1 and x2 are the two unknown variables. We can use the two equations to solve for the two unknowns simultaneously and ultimately get a vector v, which is represented by matrix x1 and x2. And now for an example. Oh my goodness, Mr. Eigenman is here himself to explain this example. Here he is.
All right. So this is one of the problems that we have. We are supposed to determine the sourness and acidity and water content in pickles. So first of all, we set up three differential equations. So you can see the three differential equations here. Next, we take the coefficients of the differential equations and plug it into a matrix, as you can see here. So we have the matrix A. Next, we use the help of Mathematica. We plug in all the values into Mathematica, and the output will give us the eigenvalues and eigenvectors as shown. This is our final result. As you can see, there are constants C1, C2, and C3. To solve for these constants, some initial conditions must be given in order for us to find out these values. And I think that's about it we have. So thank you so much.